if x1, x2, and x3 are the root of this cubic equation, we are to show that the sum of the cubes of x1, x2, x3 is equal to this. So if you look at the cubic equation, we have x cubed plus ax squared plus bx plus c equals 0. And if x1, x2, and x3 are the roots, it means they are the solution to the equation. So by direct substitution, we have ax1 squared plus bx1 plus c, we're going to be having 0. And when you do the same substitution for x2, it becomes x2 cubed plus ax2 squared plus bx2 plus c equals 0. And for x3, it becomes x3 cubed plus ax3 squared plus bx3 plus c equals 0. Remember that we have to show that x1 cubed plus x2 cubed plus x3 cubed is equal to all of this. So we kind of need to isolate x1 cubed and x2 cubed and x3 cubed. So in essence, we're making it the subject of the formula. So in the first instance, let me just call this equation 1, I call this equation 2, and then I call this equation 3. So from equation 1, we can rewrite that as x1 cubed equals negative ax1 squared minus bx1 minus c. When we do the same for the second one, we have x2 cubed equals negative ax2 squared minus bx2 minus c. And x3 cubed becomes a negative ax3 cubed squared, beg your pardon. Okay, so squared minus bx3 minus c. So we can see that it has been isolated, so we can add them together, right? So when we add them together, we have x1 cubed plus x2 cubed plus x3 cubed becomes, we sum up all of this, we have negative a, right, x1 squared plus x2 squared plus x3 squared. And when we do the same for this, we have negative b x1 plus x2 plus x3. And lastly, when we sum this up, we have a negative 3c. Right. So now that we have this, we need to derive an expression for x1 squared, x2 squared, and x3 squared, as well as x1, x2, and x3. We'll be able to do that going back to the original equation, which is x cubed plus ax squared plus bx plus c equals 0. So from our understanding of the sum of root, the sum of product of root, and the product of root, we can write x1 squared plus x2 squared plus x3 squared as x1 plus x2 plus x3 whole squared, right, minus 2 x1 x2 plus x1 x3 plus x2 x3. Now going back to this equation, we know that x1 plus x2 plus x3 is the sum of roots, right, which is negative a over 1. So we have negative a all squared minus 2. Now x1, x2, x1, x3, x2, x3 is the sum of product, right? Which is b over 1. So we have b. So in a nutshell, what we have here becomes a squared minus 2b. Now we'll come back to this equation. x1 cube plus x2 cube plus x3 cube becomes negative a, right? Now x1 squared, x2 squared, x3 squared has been derived as a squared minus 2b, then minus b times, now x1, x2, x3, it has been previously obtained, right, as negative a, then minus 3c. This equals negative a cube plus 2ab plus ab minus 3c. So this equals negative a cube plus 3ab minus 3c, which you can rewrite as 3ab minus a cube minus 3c, and that is x1 cube plus x2 cube plus x3 cube as required. Now if you don't understand what I have done in this video, you can kindly refer to the other videos that I have done on the root of cubic equations. Thanks for watching.